Hello friends, so today in this video we are going to do some back-to-back questions on the king's property. So because it is very important property, so I'm going to do lots of question on it so that you get a complete practice on these type of questions. So the first question is log 1 plus tan x dx. Now to solve this question we are going to apply the king's property. So let's just apply it quick. So let us first give it a name I, and now we can just subtract this from the x. So we have 1 plus tan pi by 4 minus x. Now the question we are doing over here is very important question. Let me just show you why it's important. So now this is also I because both the terms would be equal. So adding both of them we get 2i is equals to 0 to pi by 4 log this plus this, and we have a property in log that log a plus b is equals to log ab. So I'm just gonna straight away write log 1 plus tan x into 1 plus tan pi by 4 minus x dx. Now we can actually apply a property over here, tan a minus b. So let us just apply it. So we have 2i over here, 0 to pi by 4 limit as they are log 1 plus tan x. And now applying the property over here we have 1 plus, now tan a minus b is tan a, that is tan pi by 4, which is equal to 1. So tan a minus tan b upon 1 plus tan a into tan b. So we have this into dx. Now we can see that 1 plus tan x and 1 plus tan x over here, so we can actually cut them, but to cut them we actually need to take a LCM over here. So let us just, all the terms are over here only, let me just not waste time writing these terms again and again. So into, so when we add them we get 1 plus tan x in the numerator, so 1 plus tan x plus 1 minus tan x upon 1 plus tan x. Now 1 plus tan x get cancelled and we have this. So tan x also get cancelled and we have a 2 over here. So log 2 dx, limit 0 to pi by 4, and we have a 2i over here. Now log 2 is a constant, so we can just take it out of the integration sign. We get log 2 and a x over here with limits of 0 to pi by 4. So 2i is equals to this. Now putting in the limits we have log 2 plus multiplied by pi by 4 is equals to 2i. So we can just divide this by 2i and we get a 8 over here. So this is our final answer. Moving on to the next question. So the question is 0 to infinity. So we have a different limits in this question. That is what makes this question very important, because we are going to apply bunch of concepts in this question. So we actually have log x upon 1 plus x square. Now applying the King's rule is very insignificant over here, because if we apply King's rule we are going to have infinity minus x in the bracket of log and in the denominator as well. So this is very insignificant because infinity minus anything would be infinity and we will just complicate the problem. So we just need to substitute the x in such a way that the x should vary from 0 to infinity. So if you think about the substitution, we are actually going to use some trigonometric substitution in this question. So we are going to substitute x as tan theta. Substituting this, we actually need to substitute dx as well. So differentiating both sides, we get secant square theta d theta. Now just applying the King's limits in this question, we get log tan x upon secant square x dx. So we can actually just write d theta as dx upon secant square x, and we can do a substitution here as well. But now the limits would not be from 0 to infinity, because the limits of 0 to infinity were for x, but now we have actually substituted x as tan theta, so the limits would change from, so tan 0 is 0, so we are going to have a 0 over here, and tan infinity is pi by 2. So the limits have actually changed from 0 to pi by 2 in this question. And now the use of King's property is very useful over here. So let me just write it. 0 to pi by 2 log of tan x, log of tan theta over here and theta over here as well. So theta d theta. Now log of tan theta we actually did in the previous question, and I asked you to remember this because this is very important and we get to see this again and again. So in the if you don't remember it, we are just going to apply it here as well, but I would recommend you to remember this form, because these forms appear after simplifying complex questions like we did over here. So let me just solve this for you. So solving this would use the King's property, and we can actually just term this as I. So I would be, after applying the King's property, we would have, the limits would remain the same, but we would have a difference in the bracket inside. So we would have tan pi by 2 minus theta d theta. So now I becomes 0 to pi by 2 log, now tan 90 minus theta is cot theta d theta. This is again equal to I, and we have an I over here, so adding both of them we get 2I is equals to 0 to pi by 2 log of tan theta plus log of cot theta d theta. So applying the logs property, we have log a plus b is equals to log a log b, or log a into b. So we can just write log tan theta into cot theta, which is equal to 1, because they both cancel each other out. So we get log 1, which is equal to 0. So 2i is equals to 0. This represents I is equals to 0. So the answer to this question would be 0. So let's do another question. So the question is, this question is also very important, so let me just write this for you. So dx upon 1 plus 2 tan x. Now here we don't have any problem with the limits, nor do we have any problem with the numerator, so we are just gonna apply the King's property straight. So we can just term it as I, and writing I is equals to 0 to pi dx upon 1 plus 2 tan pi minus x. So tan pi minus x is equal to minus tan x, so just solving it we get dx upon 1 plus 2 negative of tan x, this is equal to I. So negative tan x we can actually just simplify it further by writing it as 1 plus 1 by 2 tan x. Now taking the LCM and sending the things in the denominator that are left, so we have 2 to the power tan x plus 1, and there would be a 2 tan x in the denominator, 2 to the power tan x in the denominator. So we can just send this 2 to the power tan x in the denominator in the numerator, so we get 2 to the power tan x, this is equal to I again. So we have one value of I as this, and another value of I is the question itself. Now adding both of them we get 2i is equals to 0 to pi 2 to the power tan x plus 1 upon 2 to the power tan x plus 1 dx, because we have a 2 to the power tan x in the numerator in this I and a 1 in this I. So adding them we get this. We can actually just cancel the numerator and denominator to get a x after integration, so we would get a 1 over here, so we would get a x after integration and a 0 to pi limit for 2i, so I becomes pi by 2. This is the answer to the question that we did in the that we were asked over here. So let's just do a last question for this video, which is very important, and we are gonna use a question that we did above to solve this question. So we have this as our question. Now if you observe carefully, if we apply the King's property, it would not be useful, because we apply King's property only at that place where we find the denominators to be the same, so that we can add the 2i and get the numerator and denominator both same, so that we can cancel, as we saw in this question. But in this question, if we apply the King's property straight away, we are not going to find anything that is going to make the denominator same or the numerator as well the same. So we are just going to need another trigonometric substitution in this question. So we are just going to put x is equals to tan theta, because this would be very significant to apply in the substitution. So let me just find the dx, because we need to substitute the dx as well, which is secant square theta d theta. Now applying, we have 0 to 1. 0 to 1 were the limits for x, but we are going to have some different limit for the tan. So when x had value of 0, the tan would also have value of 0, because tan 0 is 0. But when x has value of 1, tan is going to have value of pi by 4, because theta is tan inverse x, and so when we put tan inverse 1, which is equal to pi by 4, so the limits would be from 0 to pi by 4. And now we are going to just substitute the values that we found. 1 plus tan x upon 1 plus tan square x is secant square x, secant square theta, because we had a tan theta in the numerator, so 1 plus tan square theta is secant square theta, and a dx over here. So dx upon secant square theta is equal to d theta. So we're just gonna substitute this thing as d theta. So log of 1 plus tan x d theta, so this is equal to I, and we had an I over in this and we had I like this also. So now just to apply this, we can actually just use the property straight, King's property straight. So we get I again over here, log of 1 plus tan of pi by 4 minus x. Now just adding both of them, we get 2i is equals to 0 to pi by 4 log a, since log a plus log b is equals to log ab, so I'm just going to write it straight. So we have this multiplied by 1 plus tan pi by 4 minus x. So now solving this again, we get 0 to pi by 4 log 1 plus tan x and a 2 over here upon 1 plus tan x, by applying the property of tan a minus b, as we did in the question over. Let me show you the question as well. So the question we did was this. We actually applied the this was the question. So we applied the tan a minus b property to solve the question. So I can just straight away get to this point, because we had this question, we did this question in the first of our questions, and if you observe carefully, we have made the form of this only in our complex question. So this is what is the benefit of remembering some of the forms, because solving some of the complex questions get us directly to the form that we are asked to learn. So we can just write 2i. So I'm just gonna apply the things from the things that we did in the previous question. So I'm just gonna get to this thing. So the answer would remain the same, that is I is equals to log 2. Let me just write it straight. I is equals to log 2 dot pi by 8. So this is the answer to our very complex question, this. So in the first question we did a easy question, and in the last we did a complex question that had the first question in it. So this is our final answer. Thanks for watching.